Let's look at another 2 by 3 example using Gauss-Jordan elimination method. So your first step is to rewrite this system of equations as an augmented matrix, just like that. And now what we're going to do is the same thing that we did in the previous example. We're going to go through this the same way every single time. It's an algorithmic process. So it's just a lot of steps that are repeated. The only thing that will be changing would be the numbers you're using, basically. All right, so we want this 3 to become a 1. How are we going to do that? Well, we're going to write down the inverse of 3, which is 1/3. And we're going to multiply 1/3 by row 1. That's all we're going to do. So the only thing that's going to be changing for the first move here is row 1. So 1/3 times 3 is 1. 1/3 times -2 is -2/3. 1/3 times 1 is 1/3. Everything else stays exactly the same. All right, now what are we going to do? Well, the same thing we did in the previous example, and that's going to be to make this 2 a 0. So once we've established this 1, it's called our pivot element, we're going to use this to make it easier to zero out every other entry. We're going to pivot through this to make this a 0, in other words. So all we have to do in terms of the notation is important, is as follows. So we are going to be changing row 2. So you write down row 2. How are we changing it? Well, we're going to make this a 0, which means we have to do what? The next thing is to write down the opposite of whatever this number is. In this case, it's -2. And then the final thing in the correct Gauss-Jordan elimination notation is to put the row 1, the row in which you just created a 1, after the value that will ultimately make this be equal to a 0. So let's see what happens. Let's see what this notation is doing for us. Well, the first thing, again, we need to understand is that row 2 is the only row that's going to be changing here, okay? So we can go ahead and rewrite row 1 because it's not going to be changing at all. All right, so row 2 now is going to be changing. All right, so let's get to it. Row 2, you go start with column number 1. Row 2 is a 2. Then what are we doing? So we're taking a 2 minus 2 times 1. 2 minus 2 times 1 is 2 minus 2, or 0. That's the whole point of creating a 1 right here. All right, now it gets a little more challenging. If you want to use your calculator to perform these computations, that's certainly fine. Let's see what we can do. So we're moving on to column 2, performing the same row operation here. All right, so here we go. 4 minus 2 times a -2/3. That's what this is doing. 4 minus 2 times -2/3. That will result in 16/3 because you get 4 plus 4/3. That's going to be 16/3. Moving on to the third column. Okay, so same row operation, 2 minus 2 times 1/3. 2 minus 2 times 1/3. That is the same as 2 minus 2/3, which is the same as 4/3, I think. All right, so notice this first column is now set. We have a 1 in the upper left-hand corner and a 0 below it. All right. So now what are we going to do? Well, we want to make this 16/3 become a 1. We have to have a diagonal of 1s and 0s everywhere else. That's what we're looking to accomplish here by going through the systematic approach, which is GJ, Gauss-Jordan elimination method. So we want this to become a 1, which means we're going to write down the reciprocal of that number, 3/16, and multiply it by the row in which it's located, which is row 2. So row number 1 still stays exactly the same. we can rewrite that. Row 2 is the only row changing here. 3/16 times 0 is 0. 3/16, moving to column 2. 3/16 times 16/3 is 1. That's exactly why we're doing this. All right. Finally, in column 3, 3/16 times 4/3 is what? 4/16, so 1/4. Almost finished. All we have to do now is make this negative 2/3 become a 0. So let's see what we can do. It's going to be, again, guys, very repetitive. And actually, I'm aligning these now, right above one another so you can see how they are very similar. Okay, I'm trying to keep my work nice and neat and organized. All right, so with that being said, what row is changing here? Well, row 1 is, because I want this to become a 0, and that's in row number 1. So we're going to write down row 1 first because that's the row that's changing. This is the appropriate notation going through this process. The next thing I'm going to do is write down the opposite of this number. The opposite of this number is a plus 2/3. And the final thing I'm going to write down is the row in which my new pivot entry is located. All right, this pivot element, which is in row 2. So do you see how similar this is as compared to the previous time we went through this process? All right, so let's finish this thing up. Row 1 is changing. Row 2 is not. So I'm going to go ahead and rewrite the elements in row 2. All right, here we go. Going from left to right. Okay, so row 1, 1, plus 2/3 times 0. Well, 1 plus 2/3 times 0 is 1 plus 0, which is 1. So note, this column stays exactly the same. Moving to the second column here. So row 1, negative 2/3, plus 2/3 times 1. This is the whole point of doing this, because you get negative 2/3 plus 2/3, which of course is 0. Final step, column 3, 1/3 plus 2/3 times 1. When you do 1/3 plus 2/3 times 1/4, you end up getting 1/3 plus 1/6. And I believe 1/3 plus 1/6 is the same as 1/2. All right, so therefore, you don't have to put the therefore if you don't want to. X is equal to 1/2, Y is equal to 1/4. So in other words, you have an ordered pair at 1/2, 1/4. This is exciting stuff, isn't it?